For 10b, now that you know the equilibrium concentration of H+, calculate the pH. So all you do is, for the pH, is you take the negative log of the H+ concentration, which is 0.036, and you get 2.45. So find the pH of a 0.85 molarity solution of HCN, whose Ka is 4.9 times 10 to the negative 10. So this is the equation that you need, and then you just plug in your knowns and unknowns, and you get 4.9 times 10 to the negative 10, which is equal to x squared over 0.85. And then you solve for x, which is also the concentration of H+, and you get 2.04 times 10 to the negative 5. So then for the pH, you take the negative log of that concentration, and you get 4.69. Number 12, find the pH of a 0.5 solution of ammonia, whose Kb is 1.8 times 10 to the negative 5. So, for this, you first you basically do the same thing, but you have Kb is equal to, and then you have your entire equation, so you have NH4 plus times OH minus all over NH3, and then you just plug in your knowns and unknowns and solve for x, and which is the OH minus, the concentration of OH minus, and you get 0.003 molarity. So then, and that gives you, if you do the negative log of that number, it gives you the POH, which is 2.52. And then in order to find the pH, you do 14 minus 2.42, or 2.52, I'm sorry, and then get 11.48. So onto the practice problems. What is the pH of a 0.34 molarity solution of HNO3? And you just take the negative log of 0.34 and get 0.47. For number 2, you have to do an equilibrium problem, because it's a weak acid. So you do 6.34 times 10 to the negative 5, which is equal to x squared over 0.34 minus x, and when you solve for x through your calculator or whatever, you get 0.0047, and then you just take the negative log of that number and you get 2.33. So then, why are weak acids called weak? And what is the relationship between a weak acid's Ka value and the pH? Weak acids do not dissociate completely, and then the relationship is the larger the Ka, the lower the pH is. So, then to find the Kb, you look back at the equation, Ka times Kb, which is equal to 1 times 10 to the negative 14. And then you just to Kb is equal to 1 times 10 to the negative 15, and divide by the Ka that they gave you, which is 1.7 times 10 to the negative 5. So then you get Kb is equal to 5.88 times 10 to the negative 10. To find the pH for this problem, you do 1.7 times 10 to the negative 5, which is actually the Ka they gave to you in the previous problem. And then you set it equal to x squared over 0.16 minus x. And then you find that x is equal to 0.00164. And then you take the negative log of that number, and you get 2.78, and that's your pH. To find the Ka, you take the pH, and you actually take to the negative log, because if you think about it, you want to go backwards and find the concentration. And you would, so to go backwards of a negative log, you do 10 raised to the negative number that you got. So 10 raised to the negative 2.5, and you get 0.0032. And then to find the Ka, you just take that number and square it and divide it by 0.25, which is the molarity, minus 0.0032, and you get 4.05 times 10 to the negative 5 for your Ka.